नमस्ते दोस्तों, स्मार्ट माइंड्स ट्यूटोरियल्स में आपका स्वागत है। आइए आज कुछ नया सीखें।
Let us cover division by t from Laplace transforms. So let me give you the theorem. If L of f of t is equal to f bar of s, then L of 1 by t f of t is equal to integral s to infinity f bar of s ds. This is the property for division by t. Now let us cover a few problems. So the first problem is find L of sin t by t. Now we know that L of sin t is equal to 1 by s square plus 1. That is f bar of s. Now division by t, what do you have? Division by t we have L of sin t by t is equal to integral s to infinity f bar of s ds is equal to integral s to infinity 1 by s square plus 1 ds. So that is equal to tan inverse s from 0 to infinity. What is integral 1 by s square plus 1? It is tan inverse s. After integration, we need to apply the limits. So that is tan inverse infinity minus tan inverse 0 s. Here the limit is s to infinity. So tan inverse infinity is pi by 2 because tan 90 is infinity minus tan inverse x. Now from inverse trigonometric functions, we have a property pi by 2 minus tan inverse of s is equal to cot inverse s. Take the next question. Find the Laplace transform of sin at by t. Now we know that L of sin at is equal to a by s square plus a square. That is equal to f bar of s. Now division by t. Division by t, what do we have? L of sin at by t is equal to integral s to infinity f bar of s dt. That is integral s to infinity a by s square plus a square ds. That is equal to a into 1 by a tan inverse s by a. This is integral of 1 by s square plus a square from s to infinity. A get cancelled. That is tan inverse infinity minus tan inverse s by a. That is equal to pi by 2 minus tan inverse s by a. That is cos inverse s by a. Take the next question. Evaluate L of 1 minus cos at by t. Now we know that L of 1 minus cos at is equal to, if you separate, you will get L of 1 minus L of cos at. L of 1 is 1 by s minus L of cos AT is S by S square plus A square. Now we are taking division by T. So L of 1 minus cos AT by T is equal to integral S to infinity, this entire thing. That is 1 by S minus S by S square plus A square ds. So that is, what is integral 1 by S? Log S minus, what is integral S by S square plus A square? It is log S square plus A square. Now apply the limits S to infinity. Now, how can we write this? Now what I will do is, I will multiply and divide by 2. So that is 1 by 2 into 2 log S minus log S square plus A square from S to infinity. Or else directly we can do one thing. Yeah. Now that is 1 by 2 into 2 log S can be written as log S square from logarithms minus log S square plus A square from S to infinity. Now this can be written as log S square by S square plus A square, because we know that log A minus log B is log A by B from S to infinity. Now let us apply the limits. So you will get, now if I divide the whole on the whole by S square, what will I get? We will get log 1 by 1 plus A square by S square from S to infinity. That is equal to 1 by 2. Now we can write this as log 1 minus log S square by S square plus A square. That is minus 1 by 2, because log 1 is 0. Minus 1 by 2 log S square by S square plus A square. That is equal to log S square by S square plus A square whole power minus 1 by 2. To remove the negative power, you have to reciprocal S square plus A square by S square. And to remove this power 1 by 2, we will take the square root. So take a note here, L of 1 minus cos t by t. Now next time in any problem, if this one comes, you can directly use this log root over S square plus 1 by S. Here what did I do? I put A is equal to 1. Understood? You can take it as a formula. Take the next question. Find L of e power minus at minus e power minus bt by t. Now L of e power minus at minus e power minus bt by t. This is integral s to infinity 1 by s plus a minus 1 by s plus b ds. What is integral 1 by s? Log s. So integral 1 by s plus a will be log s plus a minus log s plus b. After integrating, apply the limits s to infinity. So that is, this can be written as log a minus log b is log a by b. So this can be written as log s plus a by s plus b from s to infinity. This can be written as limit s tends to infinity log. Now we are dividing numerator and denominator by s. So you will get 1 plus a by s by 1 plus b by s. As s tends to infinity, 1 by s tends to 0. Okay. Minus log s plus a by s plus b. Okay. So that is equal to, now as s tends to infinity, 1 by s tends to 0 means what? Wherever you have s in the denominator, that will become 0. So a by s will become 0, b by s will become 0. So this is log 1 minus log s plus a plus log s plus b, because log a minus log b is log a by b. Log 1 is 0. So the final answer is log s plus b by s plus a. Take the next problem. Find L of 1 minus cos t by t square. So what is L of 1 minus cos t by t square? Can I write this as L of 1 by t into 1 minus cos t by t? This is first equation. First let us find out L of 1 minus cos t by t. That is integral s tends to infinity. Whenever you have division by t, you can take this. Integral s tends to infinity 1 by s minus s by s square plus 1 ds. That is integral 1 by s is log s minus integral s by s square plus 1 is 1 by 2 log s square plus 1. Here what I am doing, multiplying and dividing by 2. So it is in f dash of x by f of x form. We have a formula, integral f dash of x by f of x is log mod f of x. This formula I am applying here. Understood? That is, now if I apply the limits from s to infinity, what do we get? We will get 1 by 2 into log s square by s square plus 1 from s to infinity. Here also I am multiplying and dividing by 2. See, when I am dividing by 2, I am multiplying by 2 to both the terms. So here outside I am dividing by 2 and here I am multiplying by 2. So that is how I got this. Now 2 log s can be written as log s square, right? Now this is equal to minus 1 by 2. If I apply the limits, log s square by s square plus 1. If you want to take this minus inside, you have to take the reciprocal 1 by 2 log s square plus 1 by s square. Therefore, L of, now I am taking one more t inside. Division by one more t. That is equal to integral s to infinity 1 by 2 log s square plus 1 by s square ds. Now here, if I take this 1 by 2 outside, now we will apply, we don't have any direct formula for log. So I will write into 1 and this I will apply UV rule. This is U, this is V. So if you apply UV rule, what will you get? U as it is. Derivative of V is S minus integral S to infinity S square by S square plus 1 into minus 2 by S cube into S. Once again I will write UV rule formula. Integral UV rule dx is U integral V dx minus whole integral d by dx of U integral V dx whole dx. This is UV rule, integration by parts. Okay. So what will you get? On simplification, 1 by 2 into limit s tends to infinity s log 1 plus 1 by s square minus s log s square plus 1 by s square plus 2 integral s to infinity 1 by s square plus 1 ds. That is 1 by 2 into limit s tends to infinity s into, now how can we write this? We have an expansion here. 1 by s square minus 1 by 2s power 4 plus 1 by 3s power 6 plus so on. This is the expansion of log 1 plus 1 by s square. Then again minus s log s square plus 1 by s square as it is plus 2 tan inverse s from s to infinity, because integral 1 by s square plus 1 is tan inverse x. Now apply the limits. So what do you get? 0 minus s log 1 plus 1 by s square. This entire thing will become 0. Now I am writing this plus 2 into tan inverse s. If I apply the limits, what we will get? Pi by 2 minus tan inverse s. See here what rule I applied. Since log 1 plus x can be written as x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus so on. This step how we got, I am showing you here. Understood? So that is equal to cot inverse s, because pi by 2 minus tan inverse s is cot inverse s. Cot inverse s minus 1 by 2 s log 1 plus 1 by s square. This is the final answer. Take the next topic, Laplace transforms of derivatives. So what is Laplace transforms of derivatives? If f dash of t be continuous and L of f of t is equal to f bar of s, then L of f dash of t is equal to s f bar of s minus f of 0. Now let us take some problems. Using this concept, you have to find the Laplace transforms. So find the Laplace transform of number 1, e power at, number 2, cos at, number 3, t sin at. Using theorem of transforms of derivatives. First, let us take the first bit. First bit is e power at. Now let's say f of t is equal to e power at. Then what is f dash of t? What is the derivative of e power at? E power at derivative is e power at. Then again we have to find the derivative of at. That is a. So that is a e power at. And f of 0 is f of 0 is how much? F of 0 means what? In f of t, wherever you have t, you put 0. So that will become 1 because e power 0 is 1. Now let us take L of f dash of t. That is s into L of f of t minus f of 0. So that is L of what is f dash of t? F dash of t is a e power at is equal to s into L of e power at minus 1. So here we can take this term to the left hand side. You will get L of e power at minus s into L of e power at. This is a e power at is equal to minus 1. That means a outside, a minus s. Otherwise, we can take this a outside and e power at inside. So if we take L of e power at common, we will get a minus s, that is equal to minus 1. Therefore, L of e power at is equal to minus 1 by a minus s. If I take this minus in the denominator, we will get 1 by s minus a. This is the formula we derived. Actually, we have this direct formula, but here is asking us to find Laplace transform of e power at using transforms on derivatives. Now let us find the second bit, that is cos at. So let f of t is equal to cos at. Then what is f dash of t? What is derivative of cos at? Minus sin at into a. So that is minus a sin at. This is f dash of t. If you differentiate it again, we will get f double dash of t, that is minus a square cos at. Therefore, L of f double dash of t is s square L of f of t minus s f of 0 minus f dash of 0. Now first let us find out f of 0. F of 0 is cos 0. Cos 0 is 1. And what is f dash of 0? Minus a sin 0. And we know that sin 0 is 0. So the whole thing will become 0. Then L of minus a square cos at is equal to s square L of cos at minus s into 1 minus 0. So that means minus a square L of cos at minus s square. I am bringing this term to the left hand side. Minus s square L of cos at is equal to minus s. That implies minus of s square plus a square into L of cos at. I took L of cos at common is equal to minus s. Minus minus cancel. So L of cos at is equal to s by s square plus a square. Now let us take third bit. Let f of t is equal to t sine at. Then if you differentiate it, you will get f dash of t is equal to, here you need to apply UV rule. What is UV rule of differentiation? U derivative of v plus v derivative of u. So that is sine at plus at cos at. Now again differentiate it, f double dash of t. So you will get sine at derivative is a cos at plus a is a constant. Now we need to find UV rule between t and cos at. So you will get cos at minus at sine at. That is equal to 2a cos at minus a square t sine at. Also, what is f of 0? F of 0 is 0 and f dash of 0 is 0. Now L of f double dash of t is s square L of f of t minus s f of 0 minus f dash of 0. That is L of 2a cos at minus a square t sine at is equal to s square L of t sine at minus 0 minus 0. Now if you take all terms one side, what do you get? You will get 2a L of cos at minus a square L of t sine at minus s square L of t sine at is equal to 0. That implies minus of s square plus a square L of t sine at is equal to minus 2as by s square plus a square, which implies L of t sine at is equal to minus minus cancel 2as by s square plus a square whole square. This is the final answer.